Hello, everybody. My name is Riza. I used to run a blog called Elixir in starting in 2013. I remember that time Elixir is version 0.11, I think. And I use this blog to force me to learn Elixir because I have interest in Erlang, but somehow I cannot grasp the syntax. So then Elixir came in Hacker News and I pick it up and I try to learn by writing blog posts every week or two. And I stopped in 2016. This is last two meetups, offline meetups that I talk about Elixir in one in Singapore Elixir Erlang meetup in 2016, and the last one in Indonesia in Jakarta in group called Lambda Indonesia. I talk about the same topic about Phoenix and Elixir, and life gets in the way. I create a startup coding bootcamp, but not about Elixir. It's not Elixir related. It started as full stack JavaScript bootcamp until now, and I started live streaming in 2018 because I want to practice talking in front of camera. At that time, we try to build online learning platform. So I have to build a course, the content. So I have to face the camera. So I try to calm my nerve in front of camera by live streaming. And I may produce one or two Elixir related course in that platform. I don't know anybody buy it or not. And the live streaming got more intensive since pandemic in 2020. I cover a lot of topics about mostly front end like Svelte, TypeScript. Or I try to learn Go as well, Python, CSS, and anything else. And of course, Elixir and Phoenix and 5K subscriber letter. Then I post this on my Twitter about how Elixir can save 2 million US dollar at Pinterest, and it blows up. It's spark a discussion, and I see a lot of interested in Elixir in Indonesian developer community. So I try to do a live streaming for Elixir again every Monday at 8 p.m. I do read the documentation, learn and read documentation page by page. And yeah, that's it. Thank you very much. If you have a suggestion, please send me a DM or please share my YouTube channel to Indonesian people. Thank you.
Thank you. What I liked so much is that I'm shocked and jealous about how you got so many subscribers when most of your content's about Elixir. It's
Yeah,
not easy to get so many people unless you're like a superstar or you're very heavy into marketing. And the even more interesting part is that you're doing it in Bahasa, is that right?
yeah, in Bahasa Indonesia, yeah.
So that's Indonesian local language, if I remember
Yes,
correctly. So
correct, yeah.
that's really amazing that you can get so many people.
Mostly my subscriber are front-end developers. So I trap them to learn Elixir and LiveView, Phoenix LiveView, because they came for front-end stuff, and I trap them to learn Elixir.
Great. Is there any questions for Riza?
Yeah, I have a question. Is the documentation available in Indonesian? Like the intro
Oh,
docs?
I don't think so. I think Elixir School have Indonesian translation, but in the documentation it's in English.
Yeah, I think somebody can submit, right,
Yeah,
translations of the docs. Yeah, that
yeah,
would be
that's very
awesome.
very good idea. Yeah.
All right. If no other questions, then we can move over to Bonnie.
Okay. Yeah, thank you. My name is Bonnie Wailee Kwong. And I I just created a website for writing poetry because I'm also a poet. But they have two books of poetry being published. And yeah, I just figured I would write two lives and create a website to so people can like art collaboratively. So when y'all see a green website here with some gray boxes,
Yeah, I can see it.
okay, so this is my website, lecture.earth. And so these are run with columns. The first one is state build-up. And the other ones are just, columns that I wrote collaboratively with other people. So you see there's two words in the Chinese. So just to let you know, this website was built on top of Christmas words to do tricks. So this built, just a sample application that's open source for everybody to use. Well, I just piggybacked my website on the code, really. And so if I go to the dashboard, I'm signed in already. This is Bulldozer. And so I'm going to go to my dashboard. All pretty. Look, and we see a bunch of columns that this user has composed. So let's try to have a minute and explain what a renku is. So a renku is a Japanese poetic form. It's a question and answer style poetic form, in which the first line of the poem says the scene, and then from there, various poets will compose different lines, and then you have a collaborative poem. So one of the ways to use this website is to do what we're doing now, which is, to get together, loading, and start writing. Click the new record button. And so I want to ask you all to just throw an idea out there for a title for a poem. Anything, really. No, I didn't start. I'll say something.
I got one. How about a flower in her hair?
Good. And how many lines do you think this prompt is going to be?
Okay. Well, let's say 4.
Okay. So I just hit the save button, and there's the beginning of the poem, and so the real line grabber, and somebody else can compose the first line. Or 2 years. Yeah. Or you can continue, then the better. And then bear in mind that, this dog can be, for all I know, it could be a dog. Sometimes, it doesn't have to be really consistent from one line to the next. Well, that out, Chris. You can't. You said long? So I was to be like, where does this poem take place?
Should it be something? Could it be something like a red rose or something like that?
Perfect. So I'm putting this in. Now I'm putting it outside. So at this point, yeah. So that's great. So the same line. Then you will anything. And about the one's works. Oh, this is dog. Right now, okay. It's funny. Well, it's fine. Whatever happened, I just hit the little line down and it's a lot of them. So yeah, anything really. I mean, I'm just who has this? What does the hair look like? What else? Where's the set? What else is there? And I mean, it doesn't have to be about the roads even. It could be about something else entirely.
How about walking down the road slowly? Sorry.
So walking down the road. Now, lady. So like it. It's a long thing. But still couldn't hit dog. We don't have to wait. No, we don't have to narrow it down.
Well, I know it has to be somebody different, but I can keep going. How about it falls down? It falls down to the floor. And withers.
Anyone else have anything between?
What?
When I'm hitting enter, and then it says, yay, we can publish the poem. Now, do we want to publish the poem? If we treat this poem as do you want an introduction? Do you want me to say this is by so and so, or do you want your name on the front page?
I think it's okay. I think it's okay as is.
Okay. So yeah, whoops, yeah, see that? It's some kind of pull something. Okay, so I published this, and yeah. So this feud. This is about actually much of this is in Chris records to do track. Really, I know a lot of code by Megan Sorrow, which is wonderful. So then we go back to the front page and scroll down, and there it is. So it's a very, very simple website for, and this is one that we can, this is one we can write poetry together. Just create a survey, create an account, sign in, and the person sign in will be in the dashboard. And then, yeah, you're literally up. So that's one flow. And then there's another step, which involves sending invitations. So if you look at this tool, you might do it in line. Let's see. Let's start. Well, this is okay, right. And I'm gonna come in a gathering. Does anybody have anything to say? Maybe spreading a new dominant pilot. Would anybody have any new ideas or a new line for this existing plan? Let's start looking at entirely. I just want to demonstrate another flow. There's another like an invitation zone. Really, I don't know about anything in the world at all. They're out of the world.
Hold it up.
How about we go with what's behind me here? A beautiful river.
Really, and how many lines is this?
Let's go with 2.
Okay, scroll down. So this is like in this. So if you decide to write the first line, so yeah, what is the first line?
For the first line would be a snowy peak and clouds.
Okay, I'm reading it, and so you see this little tentacle there. So that's what's in advance. It's not live now for legal reasons. I have to, go through GDPR and all the privacy and a lot of privacy things. But let's just say, we're sending somebody a email. This is why it gets complicated because, this person, let's just say we send myself an email because really what we're sending in them. But it's when it's a fellow, what I really to this. I mean, sounds like an invitation to the poem. So there's an invitation created successfully, and in this, what I would see is an email, said saying, one friend has invited you to continue this poem. So the invitee would say the invitee would see the title and the first line, and then the invitee would then includes the second line, and then they would invite the other person. So this is known as this is borrowed, and each person would only see the previous line. They would only see one line. So if you compose the second line and invite the third person would only see the second line, and so on and so forth. It's only working in dev right now because for some reason I've been having a lot of trouble getting around those anti-spamming laws. When I really have to read the carefully and make sure that I got all the lines and crossed all the T's. Essentially, this is known as an exquisite course, which is visual artists, realists started this game where you would only, each person would only see part of a drawing that the previous person sells them, and they will continue to drawing sold as a paper, give it to somebody else, so that it's like it's like this the imitation slope for the game where every person only sees the previous line, so the line becomes somewhat surrealistic and distorted. So that's the set and flow which only Gibson does. And so these are the two ways that you can write a poem on the site. So with the invitation flow, once the massively noticed line is reached, then the initiator of the poem has the option of hitting the publish button. So
Well,
I haven't. I'm wondering if I should go ahead and show this in dev, or I haven't fired up a dev server in a long time. I don't know how much time I have. But essentially, this is the site. It's very, very simple. The goal is just simply to publish Plangora on the front page. So it's like a literary branding. So I mean, I don't want to take up everybody's time. I think I'll stop for now.
okay, awesome. Sorry, I had to run outside for something emergency, but I'm about to get back to my chair. Is there any questions for the Bonnie?
Yeah, what all?
But for Bonnie, then I suppose we're on to the main event. Jose, I mean, how would you like to do this?
Hello, it's a Q&A. We can do both written and people can ask by video.
Yeah, I do have a couple of questions. One question that pops to my mind that I couldn't find the answer to. In Elixir, when you have a anonymous function saved in a variable or bound to a variable, how come you have to use a dot before you use the function call?
I wrote an article about that. It's called Why the Dot on the Dashbit blog, and it explains why it works like that and why functions and variables, they need to be into different namespaces.
Hi, Jose. I have a question. So I have been exploring a little bit of machine learning ecosystem in Elixir, and in my toy projects, nx.serving does awesome job. But I have a few questions. What would be the use cases where I would need to reach out to Rustler or some things for which Python has a library I can pip install and off I run, but probably I'll have to do a little more massage to do the same in Elixir. So you are more aware about the ecosystem, and the question is around what can I foresee ahead? These are the things that I might want to reach out to Python or Rust via Rustler for, and these are the things that I can do in pure Elixir.
Yeah, those are good questions. So for Rust, because exactly as I said, because we can call Rust from Elixir, for me, I would treat it more as either an optimization. So you're working on something and then the performance in Elixir is not good enough. You're like, okay, I'm going to write this thing in Rust and I will integrate with it. Or if you want to do something that we don't have a library in Elixir, and there is a library in Rust, and then instead of implementing everything, you realize it makes more sense to integrate with the Rust library, and then you use it. For Python in particular, it gets a little bit more complicated because the integration between Elixir and Python or Erlang and Python is done through or you have like separate services depending what you're doing. Those are two completely separate things. Or you have to shell out the Python program. So those will be your options. But then like when exactly you're going to need it, it's really going to depend on the problem that you're working on. I'm going to post another link here, which has a summary of the numeric Elixir ecosystem and the packages and the things that you can do in Elixir today. But that's kind of like how you can integrate with them. So you can integrate with Python as a separate program, a separate service. With Rust, you can integrate directly, and that means that it's much more easier, I think, to bring like, especially because we are talking about machine learning, and usually we are talking about largest amount of data. So the integration with Python is tricky because if you have to send all the data to a separate program, that can take a lot of time. So that's when I would consider them, right? Like, so Rust, we can use it when there is a library available, or we can use it as optimization. Python, I would use it when Elixir cannot solve that problem because in this domain, the integration is a little bit more complicated, can be a little bit more expensive. But when exactly you have to use these two changes a lot, right? And then with Rust, is those scenarios, Python those, but if Elixir is missing a library or not, it's going to depend exactly on the problem. I don't know if that made sense.
Yeah, thank you for an answer. It somewhat helps. Currently, I am also doing the same. I shell out to a Python program and I ask it to, when it's done, it just posts some JSON to my local host, which I then parse in Elixir, and it's kind of hacky, but works. Another question I had: what are some tips that you would like to share if somebody is running Bumblebee in production? List of not to dos, especially.
So if you're running Bumblebee in production, usually what I would recommend is don't run it with the default backend that is implemented in pure Elixir. Preferably use EXLA. And then there are a couple of things that you can do like to optimize. But the biggest one is use an X serving if it is possible and use EXLA. And then depending if you're using the GPU or not, there are some other considerations. And this page here, which I'm going to send on the chat, has like some general overview of what you want to do depending if you're using the GPU or not.
That helps. Thanks a lot.
So what would be the best way to translate Elixir's docs, forking the main repo? I mean, this is about, adding translations to the docs for other languages.
Yeah, that's a very good question. It's tricky, right? Because, so let's say we have two kinds of docs primarily. We have like the API reference, which is a documentation for each function. And we have the docs, which are, like the guides, the tutorials that we have for the language as well. So it depends on what you want to do. About API reference, I am honestly not sure how to do that because, yeah, you can fork the language, right? But because the docs, they are with the code, there is a big question of how you're going to keep them up to date, not only like with changes that come to the module, but if somebody adds a new option to a function, those things will be hard to tackle with time, while the guides, they are more like static, it's unlikely that they're going to have like large changes in them. So if you're talking about like the guides and this kind of stuff, you could fork the repository, but you don't even need to fork the repository. You can create like a empty mix project that does not have any modules in it. You just have the documentation folder and start translating those. And that would work as well. Sorry, there's a quick follow-up from Robert. Would an LLM translation fly as initial translation for some languages? I would think that yes. The translator tools, they are quite good nowadays. But if you're going that road, then maybe, we should just rely on the translation tools. I don't know. I'll try running on Portuguese later and see if it is good enough or not. One of the things that may actually be not good with the translation tools, but then if that's the case, we should just change them in Xdoc, is that they may try to translate code and stuff like that. So we need to make sure that when we generate the documentation pages, we annotate them with There's an HTML tag, I think. There's an HTML attribute we can use to say to not translate. So maybe we need to improve some things there. But yeah, it may be good enough.
I think in newer versions of the docs, I think they're working on some way where you can, instead of having the actual document in the file, have a link to a reference to where it is in a file, in another file. But I don't know how far that's come. In that case, that might be a way of working around the problem.
Yes, I don't think we implemented that in Elixir. It is implemented for Erlang OTP 27, but it's not there for Elixir. But my concern is, so there's the concern of like where we can keep multiple references, and that's one of the concerns. But to me, like the biggest concern is for things that can change, as like functions that are evolving more frequently, how do you keep them up to date? I think like when we start separating those things, then we need to version both the function and the doc. So we have to say, oh, this doc is actually for this version of the function, right? So I think it adds like a little bit more complexity everywhere. And it's a bigger problem. We'd have to think about it like more holistically, I think.
Yeah, and as I said, well, OTP 27 doesn't exist yet, so it hasn't been released yet, so it's on the way, but yeah. But yeah, you're right that keeping track of which version of the documentation relates to which version of the function and things like that, that could be very tricky, which you really have to work on.
Yeah, I assume some of the big languages like C#, which is like corporate big language, they have probably tackled this problem. So it's something we could investigate. Yeah, regarding translations, I think we had a translation of the Elixir website for China. I don't know if we have any more. But that was a translation of the website, the guides that were on the website. But I think the main lesson here is that if you just want to like translate the guides, you don't need to fork Elixir. You can create a new Mix project and keep all the documents in this separate Mix project, and then you copy and paste them in as you are translating.
And we don't need to have a one-to-one match with every line on the English. It can be like a work in progress and refer to the main guide. It's probably more maintainable. Sounds easy. Cool. Thanks.
So I have a question about about adoption. This is not really a technical question, but given that I've built a site that's out there, it's in production, and I just have a lot of questions about like when do you know that this created something that has won to other people as well. Like what is the curve of adoption? Like that I should be evaluating. How do I get the word out there? How have more listens for whether or not this will become something that other people might be interested in? We know that it's a very early stage, again.
So if I got the question right, is if you build something, how do you get it in front of other people and have other people? So for me, it was basically talking, going at events, at meetups, and talking about it and try to get other people excited about the idea. For Elixir in particular, something that I also worried about is like, I also thought like, okay, I'm going to go to an event and I'm going to tell people about Elixir, but what are they going to do after the event? Some of them, they are going to go home and they want to try it out. And then I also worried a lot about the experience of like, well, if somebody just heard about Elixir somehow and they want to try it out, they want to start a small project or build something with it, how can we make that experience as pleasant as possible? So that's why Elixir, since quite early on, we had like Mix New, which was a command to generate a new project so people could try things out. And yeah, so for me, those were like the two main things I would say I've done initially. And writing for Elixir as well, writing lots of documentation. There is an earlier question from George. How could one integrate the Bing with another processors like GPUs? Yeah, so today you can run a subset of Elixir if I understood the question, you can run a subset of Elixir on the GPU with the NX project. In very simple, rough lines, the way that it works is that you get a program that you can run on the GPU, and you most likely are going to write C code to get that program, load that into the GPU, and you use Elixir to talk to that C code. So you have Elixir, Elixir talks to C, the C code is going to be like, oh, all right, I'm going to put that in the GPU, and then you're going to use some C functions to send the stuff to the GPU, read things back, and the interface between Erlang and Elixir with C takes care of doing all of that. So you would use like the native integration at the C level. I'll go forward with the other questions here. So there's one from GY. Looking back on the development of Elixir, what has surprised you the most about its evolution and adoption within the developer community? Also, do you think the incorporation of set theoretic types will increase adoption? So one of the things, I have this fake title that I use for me, my company at Dashbit, which is like Chief Adoption Officer. And it's funny because when people ask me questions about adoption, usually my answer is that, of course, I work on adoption, but I don't try to have ideas of like where Elixir should be on adoption. I don't set like any milestones. Let's say I don't set any goals. If there's something that we can do to improve adoption, we are going to work on it, but there are like no goals, nor like major objectives. I mentioned this because I don't have any numbers that say, oh, I was expecting Elixir to be this, but then it got there very quickly, or it not that get there. So I don't have surprises in this sense in terms of number. It has been very exciting. It has been Elixir ability to go and tackle different problems, right? So I knew Elixir was going to be good for web development because that's where I come from. And I knew like the audience, the events I was going to talk about Elixir, a lot of them were web related. But it's really nice to see, Elixir expanding into machine learning, for example. When Nerves started, it was very exciting, very surprising. And what is interesting about Nerves is that the reason for them, like to use Elixir, it like 90% of the reasons they are actually Erlang. It's just like using the Erlang supervisor model and everything. And what they thought Elixir could bring on top of that to the table was mostly tooling. But that was very exciting to see. So all those things, I find them like surprising and exciting. There's Membrane with audio and video. So those are very nice projects. And regarding set theoretic types, again, like as I've kind of did a tiny disclaimer, I don't try to think about those things from the point of view of adoption. I'm not sure if it's going to increase adoption or not. It is clear that a lot of people say, oh, I would do Elixir if Elixir had types, right? But anybody who has worked with marketing and sales, you would know that a lot of people say like, oh, if you did that, or somebody who had worked with products, like, oh, if you did that, we would buy it. And then you do it and people don't actually buy it. I don't think about it that point of view. For me, like the importance of set theoretic types is because the community, a large part of the community has asked for it. And if we're going to do it, it's because we think it's the correct choice. It's going to be better for us who are part of the community right now and not for some potential people that may or may not join at the end. Francisco, you raised your hand. Do you want to add something to what I said?
I did. We tried to get Erlang in the embedded space. I think it was way ahead of its time. We had amazing results. But I remember you telling me, I want to bring Elixir in the machine learning space. And I don't know if you remember my answer, but I'm just like, you're crazy. You're crazy. It is going to be a real tough challenge. And I recall your answer. I love challenges. You answering this just brought back memories. And I think, my question here, when we go to the machine learning space, it is a lot of work. Had you envisioned that it would be this much work and this much effort when you started off?
Yes, I knew. I knew it was going to be a lot of work. It has been really fun and nice work. Machine learning as a whole, it's really, really big, and we are not doing everything. Like we're probably not doing 50% of everything that you can do with machine learning. So there has been a lot of like prioritizing, like, oh, we are going to prioritize those use cases and those use cases. And some of them we are going to do for fun because we think it's interesting, we think it's important to be the foundation. And I had a huge list of things that I wanted to do. I don't have this list anymore because either everything we wanted to do in the list we've kind of done, or it was ruled out. One of the examples, something that would be very nice, it's like, so we have all those machine learning models, and we're mostly using machine learning models. So our use case has mainly centered around deployment, how we can deploy and run those machine learning models, but not training the machine learning models. And we can improve like the tools and so on. And that's something that we want to do. But the state of the art in Python today is like people, they are using like, hundreds of GPUs. And that whole area we have not prioritized much because first, how I'm going to get 100 GPUs to test this stuff out, right? But the other is because like naturally, as people started using Elixir for deploying, we continue improving that experience and not that one. So yeah, we kind of expected it was going to be a lot of work, but we chose to prioritize some of the things. But also like one of the surprises that we had here, it's like how volatile all those things are, even in Python and like the C++ libraries that we have been using. So right now, one of the libraries that we use, which is called EXLA, we are pretty much having to rewrite it because a good amount of the C++ implementation that we use, it's being rewritten as well. That was work that we were not expecting, and it definitely showed up, and it's causing us to rewrite and do these things and this thing and this thing. So yeah, but it has been fun. Robert, I'll get right back to you because CMH, he had some questions earlier. So could have roadmap support related to Zig more. So regarding Zig integration, so integration with other languages like Rust, Zig, they're all done by the community. And I know Isaac is doing a great work with Zig integration, which you mentioned with Ziegler. I think it's important for the community, but it's not like a core responsibility of the Elixir team. So I wouldn't be able to tell you if there is a roadmap or specific support. I can tell you that there is no plan of making it like part of the language itself. I think it's something that fits perfectly the community rather. All right, Robert, can you go ahead?
So on the topic of rewriting things, I've been playing recently, for example, with Explorer, which is a NIF, right? Is on top of some Rust code, and then starting to study a little bit how the BIFs are implemented and how they're able to tell the beam about reductions. And when I guess 99% of the time when you're using other C code, that code will not be so nice to tell you how much work has been done. So is there any way or guide telling like, hey, here's how you write a NIF that works nicely with the beam, that when we use 100% CPU, is actually going to yield and your system will be responsive. And this will be a NIF, but it's still soft real time, let's say. Is there anything to do something like that? You still get some benefits of writing closer to the machine, but you don't break your server doing only one thing per core. Is that also a problem that you face in these reimplementations that you talk about, or is something completely different about like numerical precision or correctness? I don't know.
Yeah, usually what we do is that we just run those things as dirty NIFs, because dirty NIFs, if they're doing I/O or CPU, they can run as long as they want. So a lot of the machine learning integrations, Explorer, they're all rely on dirty NIFs. If you want to build a regular NIF, so a dirty NIF is going to run on a separate like thread. It's not going to run on the same scheduler that is executing your Erlang and Elixir code. But if you want to build those NIFs that they want to yield because you want to run it in the scheduler, I would believe there is documentation about this on the Erlang docs. That's where I would look. I know Erlang has some conveniences for writing C code that can yield. They have like an internal library inside the OTP source code for writing yielding C code. I don't think it's a public thing, but you could extract it out and look at there for some ideas. Outside of that, I think it would be quite hard to do any sort of like automatic thing. You need to consider those things like manually, because all the native functions that you have in Erlang, like when you call like a binary match to see if something is part of a binary or a string that is implemented in C. They have to consider the reductions in all those things. So I would say that the Erlang documentation and the Erlang source, they are going to be good reference for this stuff.
But the way to go most of the time is just go with dirty needs and make them small. And it's like way less involved.
Yeah, so if the NIF is short, if the NIF is quick, you don't have to yield. You don't have to do anything, right? So you can just use it as a regular NIF. But if the NIF is going to do any IO work, or if the NIF is going to do a little bit of CPU work, then that's what you want to do. And you want to use the dirty NIF. And that's what we do for most of the NX stuff, for example. In NX, it's interesting because what we do is that when we want to compile things for the GPU, the first thing that we do is that we build a representation of the program that runs on the GPU. So we are building this representation. So we are calling C functions, but those C functions, they are super fast because it's just like, oh, I'm creating a node for a tree, right? So those, we don't use dirty NIFs. We just use the regular NIF. There's no yielding. But then we are going to compile this thing. Compiling it can take a lot of time. So we put a dirty NIF around it, right? And when we're going to run it, it can take a lot of time. So we put a dirty NIF around it. So that's kind of how the process goes. Some people have also joined. So we are doing a Q&A. Anybody is welcome to write questions in the chat or raise your hands.
Gabriel has a question.
Yeah, I'm wondering if there's any news on the types. How is that work going? Anything we can expect? I know there's no promises, but yeah.
Yeah, so we have incorporated the core of the type system into the compiler already. So in Erlang and Elixir, we have, I'm going to put in the chat, we have like the byte syntax, right? Where you can say, I have this variable and it's going to be represented as an integer in the binary. And I have this variable, which is going to be a sub-binary as part of the big binary. So for example, we in Elixir main right now, we are performing like type inference and type checking of that code using the whole set theoretic types theory that exists and that we have been exploring how to incorporate that into Elixir. So we've gone past research and we are into developing. And this looks like very, very small, but you get to the point where we can start analyzing those constructs. There is a lot of background work that we have done in the last 2 years. And now what we can do is that we can add more and more constructs as we move forward. Yeah, so that's what we are doing right now. And I'm not sure if we're going to be able to do all of it for the next Elixir version, which is in May. So what, 3 months from now, is that we want to perform type inference in all of your patterns and guards and find out type information. So if somebody writes something like which doesn't make sense, like this, for example, you say x is an integer, and then you write a guard where it can be an atom, then we are going to say the type system is going to catch that. It's going to say that's not valid. Or if somebody writes a mistake like this. So right now we are starting only with patterns and guards, getting all the type information we can from that code. And then once we can do this, it's going to be really neat because for the next Elixir version, we are going to start using all this information now to process the module body of that function, right? So we can process the code in that function. So just to be clear, for the next version, we are going to look at patterns and guards. And then for 1.7, for the next version, which is going to probably be November this year, we also start looking at the body of the function. So if you say in a guard that something is an atom, and then you call a string to integer, right? We are going to say, oh, that thing is an atom. You cannot call a string to integer on that. And the goal is that, like those initial changes to the language, they're not going to change the language surface at all. You won't add an API for you to declare your own types. Those will be all the types that we have in the language, which is quite similar to how dialyzer works. So we are going to look at all the constructs that you have in the language, and the goal is that we'll find the bugs in your code, again, similar to dialyzer, without require you to change anything. And then later on, if everything is working out, performance is great, the error messages are good, then we can officially introduce the type syntax into the language. And the difference here with dialyzer is exactly because set theoretic types, they kind of allow us to have like dialyzer kind of semantics, like we can check your code and try to find bugs as if it was dialyzer, but is actually part of a whole type system, right? So it's like, this is a complete butchering of how it works, but you can think of like set theoretic, like our type system is what if dialyzer and an actual type system had a baby, right? So it's like we're trying to have everything together. And then the benefit is that we will eventually be able to, if it all works out, we'll be able to show all those warnings like the Elixir does, but as actual part of a type system.
I had a quick question since we're on this topic and Robert's here. Last session we had with Robert, I remember in his previous talk, you did say that you could have done typed Erlang, but I believe you said that an issue that you ran into was when you did hot code reloading, it was a little bit tricky to handle. Jose, were you aware of this problem before? And do you think that the way you're doing it now will be able to solve this problem that Robert said he ran into before?
I think that's very interesting because first we have to separate two things. So one is that implementing a type system as you're doing the language is much easier than implementing a type system after you do the language, right? Because when you're doing the language, you're going to tie the semantics of the language with the type system because all type systems, they're going to reject programs. You can write a program, you're going to look at it and say, hey, this program looks like totally valid to me. But because the type system cannot understand it or cannot prove a certain property about that program, it's not going to type check, and then that program is not going to be valid. So when you do the language and the type system together, it's much easier. And I think one of the challenges in implementing a type system for Erlang and Elixir now, 2-3 decades later, is exactly that, well, the language already exists. And we know by definition that a type system is going to reject some valid programs. So how can we find a type system that once we add it to Erlang or an Elixir is not going to reject a bunch of valid programs? Because if you add a type system to the language and it starts rejecting a bunch of valid programs, then it's not going to feel like you're using Erlang or Elixir. It's going to feel like you're using something else because there are a lot of idioms. So when it comes to code reloading, Robert, correct me if I say it wrong, but I think there are two aspects to that. So one aspect is the developer. Me as a developer, I write like some version of a process, and now I want to change that process to a version 2, right? Because it may receive new messages, right? So you have a process, it may be, or you have a protocol, whatever, it may be receiving messages, right? And then you know that there's a V2 of that thing that may receive messages as well. For this problem, I actually think that a type system from the developer perspective, I actually think that a type system would be useful because one of the things, like when you're having a process from V1 to V2 and you want to upgrade that code live, one thing that is very important, one thing that you don't want to do is that you don't want to stop handling the messages that you had in V1. You actually want to make sure that you handle all the messages in V1 and then the messages in V2. And then the type system could help you enforce that you guarantee those properties, you don't accidentally remove it. But to me, what is hard about that problem is because if you're going to be sending messages to the way the process works, because everything is happening dynamically and the versioning of the process, I'm running V1, I'm running V2, that part of the program, it's very hard to type check. So even if Erlang had a type system, the runtime, the Erlang implementation, it would still have to be dynamic because of how dynamic the messages are. And then, at that point, I would ask why necessarily we would have to bother about the type system at that stage. So I'll try to summarize, and then I would love to hear Robert's thoughts because I may be barking at the wrong tree here. But to me, it's like, I think the type system could be helpful as a way of like kind of a specification of how the process should behave and make sure that we are adhering to that specification. So the type system could help with the specification, but I think the runtime itself would have to be dynamic, and that make you question like, okay, so why do I have a type system here if all the messages they are going to have to be dynamic anyway. And this is at a time where when we were talking about type systems did not have dynamic in it. We did not have like gradual types. So yes, Robert, please.
Yes, the problem is, one, with the dynamic code handling, we're looking very much at working with a module as a separate entity. If I reload this module, it'll have to work, well, hopefully it will work with the rest of the system, which I haven't reloaded. And that was just a problem we had because with the dynamic code handling. And also, as José said, that sending messages is a problem because I can basically send any message I want to any process. If I have a PID, I can send anything, right? That's just how the system language is defined, right? And that is something you still have to be able to handle. So even if I have my whopping great system and I completely statically typed everything and I'm happy with it, there's still nothing stopping me from going just sending a bad message or any unknown message to anything. What is it going to do with it, right? So yeah, that's some problems you get when you want to put in static typing. But I'll freely admit having typing is a great benefit. Because I mean, I can just say, I'm so used to working with dynamic typing now, I don't think about it. But when you start thinking about it, you're always thinking about types. What's this function? What's the types of this function? What's it get in? What's it get out, etc.? What's it expecting? You're always thinking about these things anyway. So at least having a typing system, the way to specify types, which we've sort of got for dialyzer, but it's not very good. But even that itself would be a great benefit to try and check things. And just getting back to the whole system, I mean, that's what dialyzer does. It checks the whole system for you, even though I've got lots of components which are very dynamic. But yeah.
And dialyzer had a similar history as well as we are doing here. I think first dialyzer, you did not have type specification. First, you ran dialyzer and it would gather the information from the program. And then the type specification came later.
Yeah. And dialyzer doesn't trust what you write. If you say this function gets an atom and returns an integer, and you say that, but your function does something completely different, dialyzer is going to go after what you've written in the function for the type check, not what you say it should be doing. It'll tell you you've just declared it wrongly, but it doesn't trust you in that sense. It trusts the code, right? The code is the truth. It has to work on existing systems. That's just a requirement for it. I mean, for better or worse, we've had a lot of requirements from the very beginning for backward compatibility. I can just make one thing, like to say one comment here. Okay, this is wandering slightly, but not that much. But one complaint we've had over the years for Erlang are the libraries. They're fantastic, but they're very inconsistent. The naming is inconsistent. The function name is inconsistent. The argument ordering is inconsistent. And we say, yes, it is, because they just evolved. And they say, we'll change it for you. Then they come back and say, no, you can't do that because they'll crash our system, right? And that I can say is one thing I am jealous that Elixir could do when they started defining the language of the system. They could start off from the very beginning and say, yeah, we're going to have, for example, this argument ordering. The thing you work on is always the first argument. It's just defined to do that. And they could do that from the very beginning, and they're very consistent doing that, which makes things much easier to understand and to work with. But as I say, we evolved. We could not do that. We could not make the changes afterwards. And that's exactly the same problem with typing. You have the language as it is, and the systems you build for them as they are. Yes, you can put in typing, which is good, but you still have the problem of old ones still have to work. But it'll come. More will come. I mean, there are statically typed languages running on top of the Erlang system now, for example, Gleam, which is something completely different. But I don't know how they solve the message problem, to be honest. But yeah.
And regarding the message problem, in our type system, we just say it's dynamic. So when you receive a message, for us, it's dynamic. We don't attempt to type the messages. And there are people interested in researching this. And I basically tell them that I'm honestly not very interested because we are very rarely sending and receiving messages between processes directly. I think it's much more important for us to figure out the proper way of typing gen servers and make sure that we can write a gen server where you can cleanly model how you receive a reply, a response, and we type check that. Because so dialyzer has some type checking for callbacks, but it's very, very limited. So one of the things that we want to do, it needs to be a research topic because the type system theory does not support it, but it's like, what if we have proper set direct types theory for typing behaviors and the callbacks, where everything ties in. Because today, the way that dialyzer works and the way you define callbacks is that it's your responsibility as a developer to say that the thing that you return on init is the state that are going to receive in handle info, in handle call, right? But if the author of the behavior, the person who defines the JSON server could say, oh, that state here is actually what you received there and there and there, and define the whole specification for you. When you reply this, that thing is going to go there. If we can do that, then it becomes much easier to catch bugs on implementing JSON servers as well. So that would be my interest. Like when it comes, like Robert in his course, he says like there's sequential Erlang, right? And then there is the concurrent Erlang. We are worried on typing sequential Elixir, and then behaviors, and then maybe we get to typing processes, but I don't find the process themselves as a priority. I'm completely fine with saying, like, look, this is the dynamic nature of Erlang, and it's going to be dynamic.
Yeah, I can just agree. I mean, say being able to, for example, type check the implementation of a generic server. So at least you know inside that server you are correct with the typing, right? That your callbacks get what they expect and all things like this. The state passed around is what you expected. So just that would be a big help for it. And then you could say, yes, we can type the interface function so we can at least see that people calling the interface functions from other code will at least get the right types going in and out for it. So in a limited sense, we have something which is type safe.
What I keep on reminding people is, especially you were talking about typed messages across processes, Jose, and I mean, we looked at that research and not to discourage them, saying, this is great, keep up the great work, but the impact will be minimal for the simple reason that we still need to be able to handle those errors in the same way as we handle network partitions, in the same way as we handle corrupt state. And so what you're going to do is you're going to improve the user experience, but you're not going to make the life of the developers easier with what you're doing. We might catch the odd bug early on, but that odd bug has to still be handled in a live system because there'll be other bugs. And that's where the whole let it crash kind of philosophy comes in. It almost becomes an excuse for writing sloppy code with bugs, but which it isn't. Obviously, you want to try to avoid it. But the advantage, the gains from a programmer perspective are limited.
Yeah, the whole message can come from another node, right? How you're going to know the type that is coming from another node, the type specification.
Yeah, I think that's the problem. If you want to have real proper static typing, you have to look at the whole system.
And we see the constraints and the limitations in Go, where they've got type channels. It is much safer. You can compile to native in a much easier way, but you're still constrained in what you're able to do.
I'm kind of curious about, because Gleam is doing something, and also Erlang, I think, is working on some type of type system, right? But it seems like everybody's doing their own thing. So, problem, or are you guys going to come together?
Yeah, so Gleam is different in the sense that they go to what I said, like they started the type system with the language, and you cannot express all of Erlang programs in Gleam. It's not possible. So they are limited in number of programs that you can write because of type system. Sometimes that's done explicitly on purpose, right? You want to use a type system to restrict the kind of programs that you can write. So Gleam is separate. I would put it on a separate category. And then from Erlang, I don't believe there is anything from the Erlang OTP team itself. They said that they are interested in exploring set theoretic types, but who have been exploring is the WhatsApp team. It's called Equalizer. They have their own type system for Erlang. And I think they take slightly different trade-offs. I hope I'm not misrepresenting them, but for the WhatsApp team, they are more comfortable with saying, oh, actually, this pattern is bad, so the type system is not going to allow it. And then because their goal is to type check the WhatsApp code, they'll go and change their code to adhere to that new pattern that they think it's important. While for Erlang and Elixir, because we have to support kind of like everything that the community does, I think we have to push that a little bit higher to say, oh, actually, we're not okay with this. And to be clear, there is still a chance where once we have the type system in Elixir, we're going to say, well, that way we're writing Elixir code, it was not fine, and we are going to emit a warning until an eventual 2.0. It's just that we need to do our best to avoid doing that. And we'll go to great lengths to avoid doing that. And then there's also a net, and I forgot, there's also some research of set theoretic types into Erlang itself. And I believe there is ongoing communications between the researchers who are working on set theoretic types for Elixir and working on set theoretic types for Erlang. There is like ongoing communication there because ultimately it's going to be very, 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 very similar.
Yeah, I don't know about that work, but I can just say that, I mean, with type handling is done for Elixir, it can, I think, very, well, not as easily, but very straightforward, be migrated over to Erlang if required, right?
I think easy is actually a fair description of what it is, because the way the type system works is that because it's set theoretic types, so all the types in the program, it's modeled with a data structure that represents the sets of all possible values that you can have in the program. And this data structure is where the complexity is. Everything else, Robert, is going to be like traversing the AST and calling an operation on the data structure, like, oh, do the intersection between those things, do the union between those things. And this data structure is just Elixir code, which we could just translate to Erlang. So, and then the rest is like, oh, I'm going to traverse the AST and emit good error messages. And honestly, that doesn't look hard at all to me. I mean, famous last words, right? But I think like we'll be able to share the really hard part, which is like this data structure, which has all the mathematical proofs and this kind of stuff, so we can do certain operations. We will share that, and then it's like regular type checking. So if it works out, I really hope like we can have like more and more discussions into how to bring that into Erlang, especially because since we are effectively proving that the types are correct, we can also use that to do optimizations for the compiler, for the JIT. So
the compiler now has started doing that internally, the Erlang compiler. So it will start looking at types. If it can work out the type from the code, and this would be 100% safe that this type X, variable X here, happens to be a list, then it can use that information further down to generate a more optimal, more efficient instructions, because it doesn't have to check it's a list because it knows it's a list, or it knows it's a number, or whatever it might be. It does that internally. I don't think it generates more errors if it detects type errors, because that would break the language, right? But
that's the thing. Like that's the interesting aspect. I'm not sure how other languages they do it, because for the type system, you actually want to run it very early on. You want to run it very early on, as close as possible to the code that the user actually wrote, because you want to show like good error messages that the user is going to feel, oh, that's the code I wrote and not a custom transformation. But for the Erlang typing stuff, it's happening at the very low level, because they want to run it after you inline the code and after you've done other optimizations, so they can find more and more scenarios to apply it. And then if you're running the type checking here, only at this level, reporting warnings would be bad because the code can be very different than what you wrote. So I don't know how statically typed languages, how they deal with this. They probably have a mechanism where they figure out, like, for all the passes, the compiler passes, how you can get down here with all the relevant type information. But that's an area that I have no clue how people do it and how they deal with it. But they have to. I just don't know how.
Yeah, I don't know. As I said, for the Erlang side, it's just to generate more optimal code when it can. It's definitely not changing the language. And it is, as Jose said, it's down the final stage, right? It works out. It can look at the code and say, yeah, we know that this type is, I'll generate better, more efficient instructions working with it. And it won't make bad code wrong or anything like this. It just won't make it go faster. And just another comment about WhatsApp. They were looking at making a statically typed Erlang, but I think they put that on the shelf for the time being, at least. And
Yeah, I think that has been shelved. Yeah, you're right.
yeah.
And there is a question here, Robert, which I think you'll be the best person to answer it. What is your recommendation for implementing telecommunication protocols such as SIP in Elixir?
I can answer that
SIP?
very honestly. I have absolutely no idea. I'm not into the telecom side anymore. It's yes. So yeah, sorry, I can't help you there.
It may be that there is already an existing implementation somewhere.
Probably, if you
Yeah.
can find it.
I had a question about Jose, about like when you excited about AI and Elixir and everything of the progress in the group.
Yes, I remember now. Yeah, so for me, the exciting part is like working on new problems. That's it. And knowing that once we do that, people are going to build like a lot of exciting things. And for a lot of people, that's what is exciting for them. Like, oh, they can build all those other different applications with Elixir now that we have this tooling available. But to me, like personally, it's like, I'm solving a different problem, right? Like I am thinking about, oh, how I'm going to write a library for machine learning and doing that encapsulates like Elixir ideas. So that's very exciting for me. And that's what keeps me motivated is like the problem solving aspect, right? And, how to go from there and build something that people are going to be excited, that they feel it's going to be useful, but into actual practical use.
I was kind of curious about Jose when you went up to, say, Joe Armstrong or Robert here and you showed them, hey, because I know Elixir went through a couple of different phases, right? It was definitely an evolution. When you came up to them with kind of what you have right now and you're like, hey, this is what, I think this is some good stuff. Like, what do you think? I mean, what were you feeling at the time and kind of was there any feedback that you think kind of helped you to maybe craft the language a little bit, maybe even better than what it was initially?
I think at the beginning we started, because Robert has created many languages that run on top of their Erlang virtual machine. And I think like the early memories that I had were probably from us like exchanging implementation notes. I don't know if you remember anything, but it would be like, maybe it was even related to the shell. Like I was asking you like, oh, how you did some of the things to work on LFE. And then we would like exchange notes about things that I did differently in Elixir. I think that was it. Do you remember anything in particular?
Not really. Elixir, well, the impact of Elixir comes from many different things, right? One, of course, is the syntax. And you can always have a syntax war. I mean, there's just no discussion about that. The syntax I like, is, of course, is the best one. That's just the way it is, right? There's just no discussion about that. A couple of other things we've found interesting. Well, I can just say one comment, slightly go back there. One of the things I've always found very, very interesting for the Erlang side, and I'm guessing it's the same for the Elixir side, is when you go to a conference and then you hear people tell you what they've been doing with the language and all the new fantastic things they come up with. That really gets me every time, right? What you hear, that's totally fantastic. Like when they were having systems like that, they're written in Elixir for managing gardening. And you sort of go, wow, right? I think that's a product now, but that was when that came out and other things as well too. That's always fantastic. One of the things that is a very big difference between the heritage of Erlang and Elixir is that the way things are looked at. Elixir came much more, I think, was first oriented towards web servers, basically. I mean, Ruby on Rails, but then it's expanded at a much higher level with new things coming in. And if you look at the community, for example, the fact that Mix came in extremely early, right? Whereas Rebar took, 10, 15 years before it came up, right? Just different types of community. I think that's a very big difference for it. And the set of libraries and for various applications and doing different types of things, that's very strong, much stronger in the Elixir side. So if I want to write something in Elixir, the chances are very great I can go out and find a package that will help me do it. Much more than looking from the Erlang side. Again, it's just different view of how you look at the problem. That I think is fun. And that's also very interesting. So I can just say, one of the things I'm looking with LFV now is how I can more or less make it work, easier to make it work together with Elixir. So I can take these packages, hopefully, and use them if someone wants them. That's a big difference, right?
You talked about tooling, and I think it's not necessarily a community thing. I think it's more being a product of their respective time than a community thing itself. Because I still remember, like from early on, all you had to do when you created a new language, right? Like you would write a program, you would send it to a mailing list, and people would try it out. And some languages like Ruby, Python, they started like that, and they took like huge proportion from that, right? But when Elixir started out, and I think one of the main factors for that was the Go programming language, was that all programming languages kind of had to had built-in tooling, because all the languages that existed up to that point, including Erlang, they had their tooling, right? And the new languages that were coming up, they were coming up with tooling out of the box, and the tooling out of the box was being shown to be better and more integrated than the ones that were maintained separately, like Python, Ruby, right? So I think it was one of the things where like we had no option. It's like when people ask me like, oh, should a programming language be open source? I tell them, look, like Microsoft, they lost this battle. They had to open source everything. I don't see it like necessarily as the tooling as a product of the community or reflective of the community. It's more reflective of like when I did Elixir, if I did not do tooling, I would say would have had higher chances of failing. So it's like I have no option.
Yes, definitely. If you're making a language or a system, however you want to define it, for a group of people, expect to be able to test it and make a little test system in a couple of days to see if they're interested or not. Then, of course, you need a good set of tooling. There's just no way around that. You can say for the Erlang, if you can go and learn all this yourself, it'll take you a couple of weeks, but then you can do it, right? But that's a lot of people, as Jose mentioned, that's something that is just expected in the system, which it wasn't back then. Again, depending on what type of products you're looking at, they were coming. If they're going to make something that would take a year to develop and had to live for 5 years, then learning a couple of weeks for tooling is just not, doesn't make any difference. But if you want to get something running very quickly, then of course you need good tooling. So you just have to have it, right? Otherwise the system's not interesting, really. And that's one thing we just never did from the beginning. I think that's one thing that just attracts a lot of people to Elixir compared to Erlang, is that you have all this stuff from the very beginning to work with, and it's all there. I can pop things up, and all the libraries and all the applications and things there. I develop my system. I mean, that mightn't be from the very beginning, but now I can do that. I've just got these packages. What do I want to do if I want to write a web server? Well, I've got Phoenix for doing that. I've got Ecto for the database. I'm almost already there. That I think is a very big benefit to do that. But again, it also comes back from goes back to originally how when you're developing the language, what you felt was necessary in a different way, right? Like you mentioned, you just have to have build tools. Otherwise, it's not interesting to a large group, right? And it's just there. And so what you do, well, you make a build tool, and then it's done, right?
Regarding community, I have an interesting theory, which is, I think over time, I have the impression that communities, I'm not saying if it's good or bad, but they tend to become conservative. And my theory is that if you took an important feature from Elixir or from a language, just for an example, get Elixir, and then imagine that Elixir, when we started it, it was without protocols. Protocols are not part of the language. If I propose today to add protocols to the language, it will not be accepted. I have this weird theory of how over time, again, I don't know if it's a good or bad thing, how we adapt to what is there and the way that we can express the programs, that even features that we had today, if we were to propose them, the answer would have been no. I think there are like some cases where that's not, like there are obviously cases where that's not true. So like, for example, like adding generics to Go, which happened recently, it was like almost everybody was claiming for it. And we had features in Elixir that like when we added releases that everybody was claiming for it. That's not true for all the features, but I think there are some features that they would just not be accepted. I don't know exactly what is common to these features. I think one that is obvious, but just because it's such a large change in the language, is macros. If you have a language without macros and then you're like, oh, we are going to add macros to the language, I think like almost all programming languages, they would say no, just because of the big impact and consequence of macros. But for something like protocols, it's not that impactful. I consider it a very important feature of Elixir. I feel that people would like, no. Like sigils in Elixir, if we took them out, maybe people would be, yeah, we don't need it.
Yeah.
If it was being proposed. I don't know.
I think if people have been using your language for a while, they've gotten used to what's in there, right? And they say protocols. Why would I need a protocol? Because I can do things now without protocols that work. So why would I be interested in protocols? But of course, if I come into the language and we see something like protocol there, and I say, oh, I can use this, so I'll just start using it. I won't consider the fact whether it's new or old or whatever. It's just another tool that's there to be used, right? At the base level, I think it's more difficult to introduce lower level features, right? Which in one sense protocols are, right? Than to introduce new high levels. I mean, coming with a new package that does something, that's easy. Well, not easy, but it's easier to introduce. But coming with something at a lower level might be more difficult. Say I want to change the semantics of message passing because I've got something which is better. Right? Forget it, right? It's just not going to happen. But even if the thing might be better, that's okay. That's taking a very low level down for it. But you need to get the right stuff in from the beginning. That's difficult. And that's one problem I could just say we had with Erlang, because the language evolved over a number of years, for 4 or 5 years in total, or something like this. Just as our requirements changed, our understanding of the problem changed and stuff like this, what was necessary. I mean, it took maps came in OTP 16, the first version. That's basically 16 years we didn't have maps. Right? It's a self-evident thing to put. It's nothing strange about them in any way. They're just practical and useful, but we just didn't have them, and it worked anyway. Of course, it took a while to get them in because there were long discussions backwards and forwards, what they should look like and what should we call them and all these type of things for it. But this is just an example of the problem of introducing low-level stuff, right?
Is there any data type you think they are missing from the language, Robert, from your point of view? I mean, usually you get things with packages, right? But is there anything that you feel like, oh, this is important enough that it should be part of the language?
Some things would have been nice to get in at an earlier stage. I think something like records, or from the Elixir point of view, structs, right, would be very nice to have in very early. I know Elixir have added structs very early on, and they're using it everywhere, which is great. But that would have been something probably would have been better if you could they'd add it into the base language itself, right? Which we couldn't do because it was just too late.
We had discussions about this in the sense that with structs, you get 2 benefits from structs. Well, let's say 3. So one is that you can provide default values for fields, which you can easily encapsulate in a function. But the other one is that you can validate that the keys are valid, the keys exist. And the third one is protocols. I'm going to make a parenthesis here. One of the things that I really appreciate about Erlang design, and it's something that I typically like, is when you have one abstraction that you can use to solve several problems. Because when you have that, when it's done well, it means that there are like fewer things for the user to learn, right? Because the things that you have to learn, they are smaller because that thing can express several things. And I think that that's the beauty in Erlang processes and everything that it can encapsulate and do, right? You get fault tolerance, you get concurrency, you get distribution, right? So for me in Elixir, when I was considering which features I wanted to make part of the language, I would usually ask like, am I adding this thing? And then, when I want to solve something else, I have to add that other one. Or can we add something that solves several problems? And structs, to me, like I was solving like those 3 problems, right? I'm getting the full values, I'm validating that the keys exist, and I'm doing protocols as well. So it feels it makes sense, right? It feels going to make it part of the language. But for Erlang, especially now that we are considering like a type system, the checking of the fields could actually be done by a type system. A type system would be able to check if the fields are right, if the fields are wrong. And Erlang doesn't have protocols. So in my mind, like the benefit you would get from something like structs in Erlang is declaring the default fields, which I can do by putting in a function. So that's why I like feel a little bit, I'm not sure if that's something that we need to have as part of Erlang. But then I have a follow-up question. In your mind, what would be the difference between records and structs? Why records, they do not fill the hole of structs?
Okay, yeah, structs have definitely one benefit. It's easier to see that it is a struct because you have this predefined key saying, this is a struct. Okay, if you've given this key, it's not a struct, well, that's your problem, right? For records, they're just tuples where the first element happens to be the name of the record, but that's just an atom. That can be anything. There's nothing saying that I'm not using this tuple with just this same tag on, which is not the record. There's just no way of telling difference. There's no way of looking at the thing itself and saying, yeah, these are the fields. I have to go look at the definition and say, yeah, it's the third field is this one. Like that. That's one thing, nice thing you can do with structs. And also one of the reasons we added records, they were added very, very, very early, is that our first user group said, yeah, they want tuples, that's great, but they want tuples with named fields in it. But it had to be as efficient to use as using the tuple directly, which means we could not have something like a map which would search for the fields. That would be slower. So we said, yeah, okay. And we were a bit lazy and just used the tuple structure, but saying that's how it works, and that's why. That's basically why they look like.
Would you implement structs then in the same way that records has done, just as syntax sugar for defining maps? Or do you think that would be the wrong way to go about it? Like just say like record map.
The problem you have to attack in both cases is the typing. I can make a tuple which looks like it's a record, it's got the name foo at the beginning, but it actually isn't the record foo. It just happens to be a tuple with that name for it, and has different sizes, things like this for it. Even if it has the same size, I cannot check it runtime that it actually is this record. The code says this is what it looks like, and if I've written my code in at compile time, it just changes all the record operations to tuple operations. That's all the compiler does, literally. So you don't have that information once it's gone. Once it's just gone, right? You have a lot more information in the basic structure yourself with a struct, so you can see that this might call the same thing, but it's actually got the fields in there that the struct expects, right? To have, you can check at runtime that it's the right type of thing if you want to. You still have the problem that someone can create something, one of these maps, which just isn't. It's got that name for it, but I think that's less likely to happen with a struct map than with a tuple record, because it's in there, right? And you can do, I think you do more checking at compile time, because if I remember correctly, the compiler will go out and check, see this struct definition, go out and call the struct module, say, do you have this struct? Does it have these fields? What do I need to do? And you can check that at compile time, which you can't do with Erlang records. You can go out and find the definition of the record and say it's that, but that's it, right? That sense, it's a better type. Yes, it's a bit slower perhaps, but it's a better type for that working with it. You still have the type problem. I mean, I could define my struct over here somewhere, and then a newer version has this one, and I have to get them to relate to each other in some way. But I mean, when you're compiling, you're going out and asking that module, what's your struct look like for that compile time?
Makes sense.
We didn't have maps, and at that time we could not implement them with maps even if we had them, because they would have become slower. That was a demand they had. Again, we're talking early 90s here, right? So it's a long time ago. And what it would look like today, I have absolutely no idea what we would do.
Which is interesting, because languages like JavaScript, Ruby, and Python, pretty much what they have in their objects is that they have like a dictionary internally, right? And today, in order to make that fast, they've built like a huge amount of infrastructure of trying to convert that thing into something that would kind of look like a tuple at runtime, so they can make it efficient, right?
Yeah. I think you always have that problem when you're designing your language, or the features in your language. There are trade-offs for it. And you have to decide what you need, what you want to do, right? And is it worth doing it? Is it worth the cost of it? Will users say this is fantastic, or will they say no, we can't use it because it's too costly, or whatever it might be? Or yes, structs are fantastic, but why didn't you make them look like this instead, which would have been much better? And the same thing with records as well too. And I can just be slightly, not sarcastic, but realistic, that whatever feature you put in, someone's going to love it and some people are going to hate it. Just get over it. And the clear idea of where you want to go, it helps you get better for what's important to me, or for this language, or whatever it might be. Do that in. The same thing with macros. If we add macros, do they actually fulfill something important? Do they add an important feature? Or is it just there because another language happens to have it?
There is a joke that every programming language has at least one of these two bugs. The first bug is that the programming language has macros. The second bug is that the programming language does not have macros.
Yeah, I can just say personally, my view of macros, that they're a path to heaven and a path to hell, right? If you use them in the right way, they provide some very good stuff. If you use them in the wrong way, they can make things that can totally incomprehensible what's going on internally. And it's just, again, it's the same tool. It's just, I don't know, you can take your pick. We were very restrictive. We had this idea that we wanted to be very clear you got exactly what you wrote. And that's what macros can break. They do break. Just, again, you have to choose what you want. Right? I know that Elixir tries generally to be quite conservative in how you use macros. Right? Warn people, be careful. Can you use a function instead. If you need to, well, then you have macros.
And there are those things, like I remember at the very beginning with Elixir, wondering if we should have a explicit syntax for calling macros, like Erlang has, Rust has, or if macros and functions, they should have the same syntax, and there should not be a syntactical difference between one and the other, which is Lisp, for example, what they would do, right? And then we ended up going the Lisp route. But I remember it was one of the questions that I debated for quite some time.
Yeah, George, yes. C macros are horrible. Well, Erlang macros happen to be based on C macros, a simplified version of C macros. And that, again, was getting back to why we have prefixing with a question mark is, again, we want to be very explicit that this was a macro. And one of the problems with other macros is that you don't know if it's a macro or not when I'm using it. If I don't read in the definition, this is actually a macro, I have no idea what's going on in there. Like everything else, some people think it's fantastic and some people think it's terrible. You just have to decide what you find is important for it. And as a Lisper, which I am, Lisp was my first functional language. One, I love parentheses, and I've just had macros from the very beginning. And you just have to be careful and decide what you want to do with them, right? I can use macros in a good way, you can use macros in a bad way. And you just have to decide and try and advise people, be careful. Use them properly, but be careful what you're doing. And I've just looking the Elixir documentation on macros, and that's basically what you say, right? And I think that's perfectly correct. So I wouldn't remove them in any way. Well, you can't, but I don't think they're as bad as such, right?
And Robert Parkus, he got it. That's exactly the point. He dropped a message in the chat saying, I always forget that def in Elixir is a macro. And that's exactly why we didn't go with a separate notation for macros in Elixir. Because if it was a separate notation, it would be everywhere. Because def module is a macro, def is a macro, K is a macro, if is a macro, right? So if we required for a separate notation, it would be in the face of the user all of the time. And then the only way to not make it in the face of the user all the time would be to make def module, def, if, all those things, make them special constructs of the language, which kind of defeats the purpose of having it after Lisp anyway. So
as I said, it's a choice. You have to make your choice, right? You have to make your choice of what you want to do for it. So in Erlang, we chose not to do it that way, which means that some things look very much the same, even though they can be completely different. Like the attributes at the beginning of a function, they all start with a minus and an at and parentheses and stuff in it. That's what they look like. But they can mean completely different things. But they just look the same, more or less anyway. And we just decide not to do macros that way. You can do a lot with the syntax for it or how you use them. And naturally, I don't dislike macros at all. I'm just used to having them all the time.
There was an earlier question from GY. Have you ever done Advent of Code, Robert?
I don't think so. Someone tell me if I have, but I cannot remember doing it, right?
Yes, every December, there is from 1st December to 25th, there is one coding challenge. And I believe I've done that.
Yes, I've seen references to it in the forums, right? That's
Yeah,
about as far as I've
exactly.
got. Yeah.
Yeah, I know Bjorn from the OTP team. He did a couple times as well. And they get progressively harder. And I believe I live streamed them twice. So Jai is asking if I would live stream them again. And I always enjoy when I'm live streaming it. I don't enjoy so much having to get ready to go on the stream every single day, but usually the experience is nice. And I would like to come back and do another series, maybe this year, but it depends a lot on many factors, availability, things happening in life. It's tricky to commit like a public appearance for 25 days, especially in December.
Yeah, there are other things cropping up in December, so yes.
Yeah, a lot of people do it to learn new languages. And we have Erlang support in Livebook.
I played a little bit with it, but I haven't got very far yet, but I played a little bit with it, so yes. So Livebook is something I really have to learn more of.
Yeah, we are missing a lot of IntelliSense features, like for completion and this kind of stuff. So if anyone here, or even you, Robert, if you want to help us on this area, it would be very appreciated.
I'll definitely get back to playing a bit more with it because it seemed like a fun thing, right? And just have to work out a good way to use it. Well, I do a lot of training. Can we use it in a nice way in training, for example, or what I think is a nice way? This way, me, boy.
I think that's like one of the best use case for it because they can just type their Erlang programs and get feedback immediately, which you can do in the shell. But in the shell, like going back and editing it, it's kind of annoying, right? And then if you need to go further back and like maybe redefine a variable, you have like to forget the variable. But with Livebook, you can just go change the previous code as well. And I think for training, it's really, really solid.
Yeah, there's something we're definitely going to have to look at because it's there and it's coming. And as you say, it speaks Erlang at the moment as well too. So it's useful in that sense. Just looking at George's last one here, message passing more than parentheses. Well, they're different things. You can have one, both, or neither if you want to. I've barely played with Smalltalk at all.
And I think that's the interesting thing that because in Smalltalk, right, like it put the message passing as part of the objects. So you have objects that they have state, they are mutable, right? So they represent time as well. They represent behaviors. They have the functions, right? Because the message passing Smalltalk is calling a function, right? So they end up encapsulating all the thing and all the dynamic aspect of it, right? And what I like about Erlang is that you pretty much get Smalltalk objects, right? And you break them into like 3 explicit categories, right? Which is like data, modules, and the process, the message passing. Again, like when I think about like going back and learning Erlang, trying to do Elixir, and trying to make those decisions, Rich Hickey, who created Closure, which is a Lisp, he also talks a lot about this, about like decoupling, right? Like he calls it like complecting, right? When you have one thing that does too much, right? It often ends up being quite hard to work with it, right? And then like sometimes you just want data, you don't want behavior, you don't want mutability, right? And then when everything is representing one place, you have to start coming up with all those different ideas for solving the problems. Like, oh, now because you put data and behavior together in an object, now you need to introduce things like inheritance to solve a limitation that you introduced because you decided to put 2 things together in the same place.
Yeah, as you say, if you do it everywhere, then it can be very difficult to keep track of what's going on. I think Joe Armstrong said that Erlang is the most object-oriented language in the world because it's based on you're sending messages and it's isolated. So that's Of course, not everyone agrees, but yes, I think having object orientation is fine if you can be selective to do it. When I want to wrap data with a set of operations on it, then it's nice. That's something like what you do when you create structs, right? You're defining structs inside a module, and then that's a very nice way you can wrap that in a lot of operations that work on those structs. That internal to operation, if you want to, then it's nice doing it. But I mean, a number is just a number, right? And what I want to do with my number, that depends very much how I want to see it, right? What I'm using it for. And as you say, I mean, I can't just keep adding operations to numbers because I want to do something with them. Right? You get different types and stuff. Yeah. Well, yes.
Yeah, unfortunately, I'll have another meeting coming up soon.
Jose, it was great to have you on. Really appreciate your time and glad that you can come on. And it's good for Robert to also be on. It's good to see the two of you rep, hear different sides and see where you guys come together, and maybe we have some differing opinions. Our next kind of keynote for next month is going to be Sasha Urich. So that should be a lot of fun. Thank you so much, Jose. And thank you again, Robert, for joining in and giving your side.
Thank you. Bye.
Thank you.
Bye, goodbye.